Welcome to David Alexander Maths Tuition. This is chapter 12a on the gradients of curves. So here is a curve, it's a quadratic curve. So what can we see from this curve? Well, we can see clearly that it's going down on the left, it reaches 0 and then it goes up on the right. So on the right hand side the gradient is positive, on the left hand side the gradient is negative, and at this turning point here at 0, 0, the gradient is 0. So just note here that we have 0 gradient. Now if we just look at the right hand side, it might be a positive gradient, but the gradient is changing. So it starts off at 0, then it's going upward, it's got a very small positive gradient. It's not that steep at this part here, but as we're increasing the values of x, this line is getting steeper and steeper. So it's got a 0 gradient here, then it starts off a little bit positive, and now up here it's getting mega positive. So all I'm trying to say is the gradient is constantly changing on the curve. On the left hand side it goes negative, then it goes to 0 at the turning point, then it's positive. And even where it's positive, it's not the same gradient throughout. The steepness of the curve is changing because it's a curve, not a straight line. So how do we work out the gradient at any given point? So what we need to do is, if I want to work out the gradient, let's say at this point here, what I need to do is draw in a tangent. Now I'm a bit scared to do this on my graphics tablet because I'll invariably mess it up. Okay, well, I've done worse ones, that's for sure. So all I need to do to work out the gradient at this point is draw a tangent to the curve. But as you can see, even with a pencil and a ruler, that's not going to be massively accurate. And all we need to do is just take the gradient of the tangent at that point by changing y over changing x, and that will give us the gradient at that point. Obviously, if we do a perfect tangent and we calculate the gradient perfectly, then we will get the exact value, but it's kind of unlikely, and that's why we do differentiation, which is what this whole chapter is about. So here is a perfect tangent. So if I work out the gradient of this tangent by doing change in y over change in x, then that is the gradient at that point there where x equals 1. But notice that but remember that the gradient where x equals 1 is not the same as where x equals let's say 0.5. It's going to be much less where x is 0.5. Similarly, whatever gradient I work out where x is 1, it's going to be completely different where x is -1, because the tangent is going down. We can see it's a negative gradient on the left hand side. The tangent is going downwards and not upwards. So that's the key thing to remember. The gradient of a curve is constantly changing, and the gradient at any particular point is the gradient of the tangent at that point. A is the point with coordinates 3, 9 on the curve with equation x squared. Find the gradient of the chords joining the point A to the following points. Okay, so we've got x squared, and we're working out the gradient of these chords, and this is the point 3, 9. So this would be 4, 16, for example. So to calculate the gradient, it's the change in y over the change in x. So that's going to be 16 take away 9 over 4 take away 3, which is 1, and 16 take away 9 is 7. So here the gradient is 7. Okay, for the next one, 12.25 take away 9 over 3.5 take away 3, and we are getting 6.5. So if this was the point 3, 9 and this was 4, 16, we are now doing 3.5, so it's a little bit to the left of this point, and we can see, oh yeah, it's not quite as steep, which is why the gradient is a little bit less. So this time x is 3.25, so it's a little bit more, this point is a little bit more to the left of this point. So again, I'm assuming that the gradient will be a little bit less. Well, let's just work out what it is. It's 10.5625 take 9 divided by 3.25 take away 3, and that comes to 6.25. Let's do the same with 3.19.61. 9.61 minus 9 divided by 3.1 take away 3, that is 6.1. So we can see the gradient has gone from 7 to 6.5 to 6.25 to 6.1. Will it go under 6, I wonder? Well, let's see. 9.0601 take away 9 divided by 3.01 take away 3. We are getting 6.01, so it's getting close to 6 but not under 6 yet. 9.006001 take away 9 divided by 3.001 take away 3, 6.001. So it's getting closer to 6, but so far it hasn't gone under 6. So what if we had the point which was 3 plus a value h? Now h could be literally anything, but what we're going to do is assume that h is a really, really tiny amount. In fact, we're going to assume that it's so small that it can almost be completely ignored. So let's work this out. So the change in y is going to be 3 plus h squared take away 9 divided by 3 plus h take away the x value of 3. Okay, so we can see that the 3 minus 3 on the denominator cancel. We can expand the brackets on the numerator, so that's going to be 9 plus 6h plus h squared take away 9 over h. And again, the 9's will cancel out. And then if we divide through by h, we're going to get 6 plus h. So the gradient here is 6 plus h. A moment ago I said, well, imagine that we're adding on a small amount to 3. So here we added on 0.01 to 3 and we got a gradient of 6.001. Here we added a bit more, 3.01, and the gradient was 6.01. Here we've added a 0.1 to the 3. But what if h was so small that we can pretty much ignore it? Well, if we can pretty much ignore h and consider it to be 0, then we can say that the gradient will therefore be 6. Now at the point where x is 3, and I'm drawing a chord from 3 to the x coordinate where x is 3 plus h, where h is an infinitesimally small amount, well, that's not really going to be much of a chord at all. In fact, what that is going to be the same gradient as the tangent at that point. So therefore the gradient when x is 3, the gradient will be 6. So what we can say is that when x is 3, our gradient is 6. Now notice that 6 is 2 times 3. So when x is 3, the gradient is 2x. Now the original equation was x squared. So y equals x squared, and the gradient is 2x. So what we're going to learn about in this whole chapter 12 is differentiation and how we go from x squared to working out that the gradient is going to be 2 times whatever x is.